Okay, the next problem, it is hexahedron. Hexahedron means it is a cube of 50 mm side rests with a face on HP such that one of its vertical face is inclined at 30 degree to VP. A section plane perpendicular to HP and parallel to VP. So cuts the cube at a distance of 20 mm from the nearest vertical edge of the observer. Okay, nearest vertical edge of the observer, it has to cut it. So it is like this. So it is cutting like this. It is parallel to VP, perpendicular to HP. So it is cutting like this. Okay, so it is cutting like this. If this is your vertical plane, it is cutting like this, parallel to VP and perpendicular to HP. It is cutting like this. First, I am going to draw the cube here. Okay, cube of dimension 50. First, I am going to draw an XY line first. Okay, X, VP, HP. This is Y, and we have to take a reference point here. And angle we should consider, that is 30 degree. Okay, 30 degree angle of inclination. You have to place it at this 30 degree. You can see here with a face on HP such that one of the vertical faces is inclined at 30 degree. 30 degree inclination we have considered. Okay, now I'll take a reference point. So this is my first reference point. Now, so we should consider 50 mm, right? 50 mm, 10, 20, 30, 40, 50. So 50 mm. Now we need to mark for 90 degree. Okay, 90 degree inclination we have to give. So 90 degree here also, 90 degree. Okay, so 90 degree inclination we have to show here. Done. Now we should draw a line of length passing through this point for a length of 50, that is 50 mm, because it is a cube of hexahedron of dimension 50. Okay, so A1, B B1, C1, D1. Okay, so it is done. Now drawing the thin lines to find out the center of the axis. So O1. Now projecting it upward to draw the front view. Okay, so the height also it is 50, we should consider. A dash, A1 dash, B dash, B1 dash, C dash, and C1 dash. And here there is another line, D1 dash and D dash. These things are not visible. O1 dash and O dash also not visible. Now we can see here the section plane has to be cut. Okay, here. So you can see here a section plane perpendicular to HP and parallel to VP cuts the cube at a distance of 20 mm from the nearest vertical edge. So nearest vertical edge is this. Okay, nearest vertical edge of the observer. So nearest vertical edge to observer is this. So we have to cut a section plane for a distance of 20 mm from that. So here cutting section plane will be perpendicular to VP HP. So perpendicular to HP and parallel to VP. So it is cutting like this. So we should consider a distance of 20 mm from here. So for that I'll be drawing one horizontal line here. Okay, so here I'll consider 20 mm height for showing the dimension. So this is 20. So here I am going to draw a section plane. Yes, this is also yes. So it is cutting here. Okay, now we can mention the namings here. This is 1, it is cutting on the top face, and 2, it is cutting here. Okay, and similarly it is cutting the bottom faces also, right? So it is cutting the bottom faces also. This is 3 and this is 4. Now project it. So the 1 and 2, it is cutting the top faces. 3 and 4, it is cutting the bottom face. Just project it upward. So 1 is this, 2 is this, 3 is this, and 4 is this. Okay, now draw the sectional front view. That's it. This has been asked in the question. Okay, so this completes the problem. You can subscribe for the channel and hit on the bell icon for the latest notifications.